Hey everybody, this is Larry, this is me going with Q4 of the weekly contest for 27, maximum area rectangle with point constraints 2. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. So this one is a harder version of Q2, which is constraint 1, noting that just as a quick visit, n is 10, in this case n is way bigger, 2 times 10 to the 5th, so you have to do something, well, not that slow, right? So the key idea behind this one is line sweep or sweep line algorithm. And how I come up with this one is just honestly, I don't know that many algorithms that are n log n, because basically for n that goes up to 10,000 or was it 100, 200,000, you just need a fast enough algorithm, right? And either you do something O of n or O of n log n, and that's really the idea, right? And so how would you structure this? Oh, this is an actual pen, not a drawing pen. Hang on. Let me make sure that I have it on screen. Yep. So basically you have, a thing and you have some points. And the idea here is just kind of do a case analysis thing that I have. But the first is a sweep line, right? So, and here with a sweep line, you go from left to right, without loss of generality. And then here, what happens when you sweep this line? I'm just going to draw it a little bit to the left so you can see the points. But the idea here then is that, okay, well, we have possible line segments. So this is a line segment. It goes all the way to the point, sorry. And this is a possible line segment, right? Okay, so then now we know that if we see these things in the future, then we will draw a box. And then now when we sweep to the next line, let's say here, and there are a couple of cases, I kind of just drew them haphazardly, but for example, if this point is on the same point as this, then we actually want to remove this afterwards, right? Because we know that if we kind of draw a box this way, well, even if we have a point here and we have another one here to kind of complete the box maybe, even if that's the case, this point prevents this line from being extended. So that's basically the idea, is just kind of go through all these cases. A clear one is also maybe a clearer one than this case that we just drew, is something in the middle, because then now this line or this point destroy this line segment, right? So okay. So I think, the one edge case that I actually didn't handle and didn't think about until much later on, I think this is the idea, and everything else is what I call bookkeeping. And what I mean by that is just to make sure that everything is kept in a very quick way. And this is tricky, because if you kind of do like a naive for loop thing of just like, okay, I have a point, and let's go for all the other segments that we have, that is easily n squared and you're still too slow. Okay. So the way that you would think about it is actually just, well, with a binary search, because you have this point, we maintain these segment lists, we maintain from the starting point and so forth. We know that we can binary search, and when we've searched that, we find a segment, then we just remove it, right? Pretty straightforward in theory. Implementation is also a little bit tricky, which we will get into, right? It turns out though, there is a weird edge case that I didn't figure out. I didn't even figure out that was an edge case until later on, which is actually something like this. And how this looks is that, okay, let's just say when we went to here, this is our line segment dictionary or lookup thing. And then once we kind of sweep, actually, what I thought was that initially that I should remove this, but that's actually not right? Because you can imagine that in the future, of your sweep, you have something like this, and this is clearly a box, right? So I actually incorrectly, and you watched the live portion of this, I actually thought this incorrectly. But then here comes the harder problem, is that, okay, then now we have two line segments. Then how can we kind of maintain these two things and binary search at the same time? And it turns out that, this is where you have to know your invariants. And the invariant for this is that, well, if we do a binary search, well, there are a couple of places it could be, right? It could be here, and keeping in mind that these dots cannot be on the same plane, because if that's the case, then this would have removed, then this is no good, right? Oops. Then this is no good. So that means that all the points are distinct, just to kind of put it out. But then now, that means that if they're distinct and they don't have a point inside each other, that means that if you look at these segments, it will basically go like this. It would go and then bigger and then bigger and then bigger. So in a way, this, to me, visually in my interpretation, is a stack. And here there are, like, just going back to this diagram for a second. If you do binary search, then there are only a couple of scenarios, right? It could be here, inside here, in which case, if you have a point that's here, you do binary search, you look at this, you remove it, you're happy. And then the other one is just, well, if you're here, you're on the tail, you remove this, you're happy as well, right? You remove the segment rather, right? But you see that this is inside the point. But then the tricky one, if it's here, then now you have to make sure that you maintain things in a way such that your binary search, that's the way I did it anyway, is it will hit this, and then after killing it, it tries again, right? And in a way that it feels like a stack. And the reason why I keep bringing up stack is because that's the way that you're able to prove your running time, right? And because if you don't prove that, then that means that every time you loop, if you look at the same segment without removing it, then you're going to go into an n square situation. And I actually did this as well. So that's basically the idea for this one. And it's kind of, I think this edge case was very tricky. I had most of the everything else like within 10 minutes or so, maybe a little bit longer because I type slowly. Yeah. And one more trick that I would say is that I think Leetcode has finally caught on that even though Q2 and Q4 are the same, one is that, I don't know why, they changed their wording a little bit. And in fact, they changed the input a little bit. I guess so that you don't naively submit it, but it doesn't matter, right? Because we're smart people. So what I did is that I took the code. Is this the code? Yeah. I took the code, I pasted on this part, I call it the helper, and then I just kind of convert the input from here to the new input so that we can test Q4 in Q2. I still end up with a couple of wrong answers, 2 wrong answers, because I guess 10 points was not enough, and they have stricter test, and I had some off by 1 things, and one of the cases was just I had a timeout for a reason that I was talking about. But anyway, let's go over the code real quick, or as quick as it needs to be. And yeah. Okay, so yeah. So here, the way that I set up my sweep line is that I have a points, a default dictionary consisting of list. So then now I sweep to X and then I sort them. So then basically now points of X contains all the Y's on that line, right? So that means that all the X, Y pair are the dots or points or whatever. And then this is the massive thing. It's a little bit wonky because I didn't prove boundary conditions on the contest, but it's fast, and I was trying to do a little bit more work for off by 1, so it's not quite precise, but I just want to get it right, honestly. But yeah, so then I maintain this by using a sorted list, and we kind of do the sweep from sorted order on the X, which is points.keys. And here we have a removal thing. The reason why I have a removal thing is that we can so that I delay the removal, and the reason is because if you're doing like iteration and stuff like this, and you remove it while it's iterating, or if you keep track of index and you remove stuff while you're keeping track of index, everything is a mess. So I actually buffer all my removal at the end, and I just made it a set so if we do multiple ones, it's fine, right? So okay, so first of all, we do a binary search to see to figure it out. Again, I don't know, this is probably not super precise, frankly, but that's okay, right? Yeah, because I think I don't need this one, but maybe I am wrong. Because the way we binary search, we choose the second element to be infinity, so that if it's exactly y1, it should be index -1. So I think we can remove this, but let me double check. Let's try this, right, and see for ourselves. It If not, then we'll just put it back in. It's fine. It's not a big deal. Yeah. So that's not necessary. So okay. Yeah. I mean, during the contest, I didn't want to prove, like, I didn't want to risk getting a wrong answer on proving bound. So that's why I have it. But yeah, as you can see, and the reason is that because we binary search, this is infinity. If we do a bisect left, that means that index -1 is the one that will contain y1, right? Because we're always going to be one index after that. So that's basically the idea. And if it's greater than equal to 0, because we have to check, then we just do this. And yeah, and inside the sorted list, we actually keep track of, I guess I don't point it out, but SL contains three things, which is starting y, ny, and then the previous x is what I call it, right? And this is basically, this represents one segment on the y that we talked about, and then this is the x where it all originated, is so that we can just calculate the area. And that's basically the way that I have it here. So if it match exactly, the starting x is this, the ending y is this, then we take a look at x, and then we just calculate best to calculate the rectangle. And then now here we remove previous things. Yeah, and this is a bisect left because we want to move, because there are cases where there are edge cases where you have to consider it as well. Let me bring back the drawing real quick. And what I mean by that is that, so there is a case where if you have 3 points, right, you actually have 2 segments, right? So that's basically, like but it only happens on the same line, because in the future, if you have like 1 extra point here, then actually this removes both of them. So we have to kind of check for both these cases, is what I'm doing here, right? Yeah, I do a bisect left, I have to check the -1 to go to the left, and I have to check the current index to check the one to the right of the point, and that's why we have it here. And here we do a while loop, and this is the kind of what I call a stack that we talk about, right? Because then now we actually, because if you kind of think about a sorted list, the way that the most inner one, it's going to be, let's say your inner one is like 10, 15, and then if you think about it as the stack that we talk about, then the slightly bigger one, let's say it's a 9, 16, right? So 9, 16 encompasses, but then it's going to be one earlier, right? So that's basically the reason why we have it like this, because, and if you search for, or something like this, right? And if we search for, say, 12, you're going to be inside here, and then we remove it, and then we just want to check the previous one. And the reason why this while loop is okay is because if this index increments or decrements, sorry, if we go to the previous one, that means that we remove one previously. That means that we're always removing. That means that we don't check the same thing more than once if we remove them, right? So that's the key part about this. And the same logic can go for this part. If you're trying to remove, say, precisely x is y is equal to 15, say, and you have like 1520 is one of them, and then your next one's 1421, it's going to go to this one, and actually maybe this is just wrong, I don't know. Maybe this part is wrong, because I think this should actually go to the, because it doesn't make sense for this to go to the next one. But I think as a result of this thing, it should handle it, because I think so, maybe not, I don't know, honestly. Maybe we have the wrong code. I don't know. Wait. I don't know. Does this work? Let's see. Right. It's always good to have hypothesis, and then we just. Yeah, I don't know. Honestly, I don't know. Hopefully, it's just weak test cases. But either way, I think like in this case, because if it's 15 exactly. Because we search for -1, this is going this case should already handle this case, so that's why it doesn't matter that much. And the numbers that come afterwards, I think this loop I just added in because I didn't want to think about it during the contest, is that like if you have, say, I don't know, the only way that you increment the next one is going to be like 21 or something. So this number can never have overlap with this. So then this never works. So I guess this just doesn't do anything. So actually we can maybe even remove this, I think. Let's try that again, right? now that I think about it. Like I said, during the contest, I didn't want to risk, testing for these things, right? So yeah, so that, I guess that didn't matter as a result. It's slightly slower but you only do one more check, right? So it doesn't, it's a constant number of extra work. So yeah. But yeah, this is basically for each Y, we just remove all of them. And the way that I thought is that in the beginning, I thought that you remove everything in between, but as the case that we drew, it doesn't matter. And yeah, and then at the end, for everything that we put in remove, we remove it. This way, we don't have to, worry about iteration error in this or anything like that. We just remove things from sorted list. Because you always, I don't know, it is very wonky otherwise. But yeah, and then at the end, we want to say for everything that we already processed, we want to add a new segment for Y from Y1, Y2, and then X, and that's pretty much it. I mean, I think the implementation like now looks a lot cleaner, but you should watch the live version if you want to see like the madness that is Larry's head and trying to get this right. But I did actually miss a real case that it took me a long time to debug. So I don't know, depending on how you want to say it. But yeah, here's the top of the code. Here's the bottom of the code. 46 lines, actually not that bad. Let me make this slightly smaller so you could see maybe most of it, at least on one screen if you want to. And that's pretty much it. So what's the complexity, right? I mean, there's going to be a lot of, this is n log n in the worst case, for example, if they're all on the same line. This is n log n also for the same reasons. But everything here, right? For each line, we only do log n operations, but this is an O of x loop, just to be clear. The sorting gives us n log n, but the loop itself is only O of n, right? And for each O of n, we do for each point on the y-axis. That's why it's a little bit confusing, but they're only in total n points, so that's fine. We do a bisect on a line, and at most it should be like 2 times n line segments for whatever reason. I don't even think that's true, but at most, if you want to be lazy on the checking. So yeah, so all these with the indexing is log n, but that's fine because it's n log n. And even if there's an inner loop, like I said, the summation of all the inner loops is just O of n, right? So that's why I say O of n, and that means that everything is n log n, everything is n log n, everything is n log n, and that's pretty much it. Everything is n log n. And that's all I have for this one. Let me know what you think. I think once you see the visualization, it actually is not that bad in terms of understanding the problem, right? But definitely you have to really flesh out your edge cases and your all these things, and it can be very tricky as you see. So the implementation is actually looks cleaner than I remember it, but you also saw me removing some code and kind of like I had a lot of code where I at the end of the day I still almost spent an hour, so it wasn't like I was like, oh, this is so. Anyway, if you do want to watch Larry struggle, definitely watch it maybe on 2x or something. I think it's kind of, like everything doesn't need to be perfect. I struggled a lot. I still finished top 200. Maybe could have been better, but whatever. Top 200, and that's fine. And that's all I have with this one. Let me know what you think. Thanks for watching, and you could watch me solve it live in the contest now. I knew that one very quickly, but I was also just being careful. Okay, let's see if I can solve this one. Is it exactly Q2 with higher whatever? Or no, this is different. You're given points. Seems like it's the same, honestly. Except for that the input is a little bit different for some weird reason. I don't know why they did this. Is it so that we can copy and paste? I mean, it's going to be the same idea. What a silliness. Okay, anyway. I don't know why they did it this way, though. So silly. But yeah, 2 penalties on what I know is... like the hard part, I got the hard part, and then I got this dumb part. Okay. Focus. Okay, how do I want to do it? So what did I do on this one? I had n cube. And now we want to do an O of n. What is anything else that's different? I guess coordinates, but actually I didn't realize the coordinates are so small, so I should have gotten this faster, honestly. I forgot about this to look at that, but oh well, whatever. Okay, I mean mine is don't care about it. Even the inputs are the same, I think. It's just given a weird way. I don't know why they make you do that, but okay. Maybe let's just make it slightly more annoying. All right. Now I just have to do this, otherwise my rating will tank. 10 minutes is a silly amount penalty for that problem, especially since I knew how to do it. I just kind of didn't think through the edge cases. And even the first time. Okay. Focus, Larry. Focus. You're on Q4 now, not Q3. Do I know it though? No, I don't think so. Okay. Oh. I mean, did I do it? Did I check that? Actually, yeah, okay. I mean, it has to be not one of these, that's why. But sweep line. How do I do sweep line? Okay, let's say we sweep line. Oh well, they make it annoying to do a sweep too. Even okay, what would a sweep line look like? That's the only way that makes sense. Okay, you sweep. You have, so you keep segments. You have a dot. So what does that mean? The dot means that let's say we're trying to sweep. I mean, sweep line is the only way that makes sense, really. So you have all these axis parallel things, and then the dot just means that now you break them apart, right? So you have to maintain certain things. So you want to maintain, nothing else has to be on the border, so you want to maintain segments. So you basically have a segment as you sweep. That makes sense, that's fine. And then when you see a point that what is the complexity, Larry? You have a lot of, you can't do, okay, binary search is fine actually, so I guess there's that. Okay, yeah, I mean, I think we got it. We just, I mean, it's slow, but we'll get it. I mean, we have an hour left. We should be able to get it. It's silly, but okay. So then we have, I don't know why they do it this way. Like I'm converting it literally back. Right. Okay. So then now we want to do points that sort, right? And then what does that mean? I don't even know that I needed to do this, but okay. So then now maybe we have points. Actually, I don't want to do it this way, but we might anyway. Whatever. We'll write new code. This is easy to write, Larry. So we have points is equal to, right. So we have points of x. We want to append y, and then now for x in points.keys. Points, we sorted, so then now we have all the xy sorted, and now we could do our sweep line. So then we have, I guess we should, I don't know, whatever. So then now we have for x in this, and then now we want to create segments of all the other ones, right? So we want to create the everything can only be added or removed once, so I think we're fine there, but yeah, I mean, I think we're fine. We're just gonna be slow. Already down to 200 because of the 10 minutes. That is just sad. Okay. Yeah. Okay, yeah. How do I want to write it? Okay, so for y1, y2 in okay, so first we want to delete all the existing stuff in sorted list. Okay, and maybe we have a best equal to -1, I think, right? And then now we have a sorted list. What we want to do is, yeah, we want to remove stuff for each point. Right, so okay. Okay, yeah, fine. For y in point sub x, it's already sorted. So then now we want to do a sorted list. We want to find bisect left of y. Yeah, okay. Whatever, -1. And then now, if the previous y is, if this is on a point, then that's fine, we can ignore it. If it's between 2 points, then that's, if it's between a segment, I guess is where we have to care about. But, in fact, I think you have to do a little bit better than that, but, yeah, okay. Yeah, okay, no, okay, yeah, that makes sense. Okay, fine. How would I write it though? Okay, fine. Okay, so then now we have, let's say left index, and then right index equal to, nope. Okay, so then now what we want is, if technically, I guess we want index right, or bisect right. No, it doesn't matter because your y1, you have a -1 as a thing, so it doesn't matter. Okay. I'm just stalling. Okay, so okay, SL of L index if this is strictly in, so bisect left means that will be the next number, but actually you want it to be the previous number. Yeah, okay. So then now if this is true, then well, one, we want to remove this, how do I want to write it? Yeah, okay. Because we have to remove the segment, right? And then if it's bisect left, so if it matches, then that's fine, but we want to go to the previous one still. I might be wrong on this one. It's fine, I don't know. And I think it's just the same idea, so I'm just gonna copy and paste. We're used to make mistakes though. Okay, so yeah, so if started is not none, then we want to remove index, say, yeah. We want to add SL start. I guess it doesn't need a thingy. If n is not none, then we add SLN, right? And then if start is not none and right, it's not none, they have to do everything in between. So then we want to do for I in range from start +1, we want to do n, yeah, that's fine. Remove that add SL of I. So then there we go, and then yeah. And then now for for t for tuple in remove sl dot remove t, right? Okay, so that's the idea. And then now we have for y1, y2 again in this thing. Maybe I could have just typed it out, but okay. Right. Now we want to see if it matches exactly, right? So now that we removed everything possibly in between. Oh, this isn't quite right, is it? So this is true, but we need an order of this is in the pen anyway, but index -1. But everything in between will add anyway, so okay. Yeah, okay, so this is just for the border, but actually what I want is, well, this part, I guess, I'm writing it awkwardly. I think we need this anyway. We call this, which is from L index inclusive to R index -2 almost. -1 is going to be the one that maybe keeps it, but we have to keep it trying. Okay. Okay, I mean, this is just, I just wanted to print it out real quick. I don't know that, I mean, just to make sure that my states are correct so far. So we have 1, 3. What does the 1, 3, 1, 3 mean? That doesn't seem right. The format is terrible. Okay, so we have 1, 1. So then you have 1, 3 on the y side, and then now you're on the 3, you have 1, 3, but they should have removed this, maybe. No, it shouldn't have. Okay, that's fine. I think that's where we're supposed to use it for math. Okay, fine. And then the second one, we have 1, 3, and then the 2 gets rid of stuff. So then it's 1, 3 again, which is maybe fine. But we probably should have another one, though. Another print statement is what I mean. For points is equal to 2, we'll have to figure it out. Oh, no. It just didn't delete this, which is actually sad. It just added it again, so this is wrong. Okay, let's see. Okay, so then now it just doesn't go. Oh, because there's no zip here. That's why. Okay, so then we have to do. Okay, because there's only 1 point. That's fine. That makes sense. And here, I think I can. Well, this never gets called, I suppose, because this is wrong syntax. But this is actually should be a set. Because in theory, it could remove multiple things, but this is still wrong though, so it is a way weird. But okay, so why is it wrong? I removed the print statement. Okay, fine. L index is 0 and right index is 1. Why? Oh yeah, we still haven't fixed this part because we didn't do the 1 point thing. Okay, so then now we want also for y in zip of, well, no, just in points of x, we want to do, right? In this case, just index, and we want to do if this, if index, yeah, remove that add sl index -1. Okay. Y1, I mean, I was hoping for an actual error, but this is fine too. Easy fix. Okay, so then now we do remove the 1, 3. That's good. That's what we want. Okay, and then now we want to say SL.bisect left of y1, I think. Now we want to match it exactly, right? So this is the index of that, and then we want to, okay, right? So then now we want index -1 to be the one that's equal to, so okay. So if this is equal to 0, then we want to check that the second item, so SL index -1 of 1 is, if this is equal to, then we do a max check of, oh, I have to keep track of the x's so I don't get the distance. Okay, I mean, that's fine. We could add that into the thing later. So then this is just going to be equal to y2 minus y1, just as a placeholder to get the max width. In this case, it should give us, if correct, this should give us 2 and 1, right? Would be better if I typed it correctly. Infinity, I don't have infinity. I usually write it in somewhere, but okay. Almost misclicked. Okay, so that's not giving me the right answer, which means that this doesn't get called, which is a little bit sad. Just to make sure that this should get called. Here. Okay. We still have almost an hour, not quite. We should be able to fix this. Here's 0, so okay. Why? Well, this should be 1 though, right? Because y1. Okay, let's see. SL, y1, y2. Okay, let's go. Oh, this is empty. Why is it empty? Well, if it's empty all the time, that's also probably not great. So we removed too much. Okay. I guess I was just looking at that one. Remove. So set is empty. Huh? Oh, I just forgot to add stuff. I am dumb. Okay. Yeah. Whoops. Whoopsie daisies. Okay, so we have 2, 1, 2, -1. That is what we expect. So we just have to keep track of an additional x parameter. And I think we're maybe good. We're on the track to a good place. Yeah. Okay. Okay. No, we just have to add it here, right? Actually, right? So then now here, right? So then now this is just this times, okay, previous x is equal to this thing. Just want to write it out. Px minus x. Oh no, the other way around. For -1, 2. So I think we're mostly good. We are going to copy and paste this into Q3. I know that they changed the input format, which is annoying, but that's fine, right? Yeah, okay. So then now I have this thing. They make it. What is it? Do they even name it the same thing? They do name it the same thing. But how do I? This is actually really silly, you know. Okay, so then I have, okay, this thing, right? So maybe I call it helper, right? And then we could just copy just this part, right? So it's fine, same thing. Yeah. So for x, y in points, x is right? And then we just return self-type helper xs ys. Just really silly that I make you do it. Sorted list is not defined. Okay, I guess I didn't copy paste that part. Or maybe I did, but then I don't in whatever it. Okay, is that the right? I mean, that's right for this one. Am I submitting for part 1? I am. Let's go. Ooh, okay, that's good. I mean, you know, it's the best you can hope for. 2044 rev -1. What is that? 94. Oh, I didn't check the borderline thing. I think maybe that's why. Because nothing could be on the border. I think that's what's going. Because there's 344 things. I assume that's the reason. Yeah, okay. So we have to renormalize this as well. Or I just want to visualize this a little bit better. But okay, I guess I could just draw it out. I see why. But how do I handle it? Oh, then I mean I guess that it should be easy to handle, because it's just that I intentionally skipped this bit somewhere. I remember doing it because of like something like this. Okay, if this is the case, I think because if it's Leetcode 2, then we also remove all the previous ones. But then maybe we have to do this part first. I think maybe that makes sense. I was hoping that I didn't need to. Wait, which way it doesn't make sense? No, okay, I think this makes sense, actually. Though I think I have to double check that. I didn't check this, so this was wrong anyway, which is that SL index -1 of 0 is equal to y1, and this, then we do it. Okay. So maybe that was kind of wrong anyway. Okay, we haven't fixed that yet, but now okay, they should be removing it, I think. I have to think about the edge cases, maybe a little bit tidy. Oh, here as well for 1 point things. So maybe the 1 pointer is the case with it. Nope, not enough. Okay. Let me think it through. I mean, I think this is right. It's just that I didn't handle this case. Yeah, because 96, 72, 72, 44. So I assume these 4 things fit a square, but this is in I could do the 1, but okay. But I assume the 65, 44 is in the way. So that means that yeah, so 65 by 44, 44 should invalidate all the things that are. So there are 2 places that it can invalidate. One is where the first thing is 44. Oh, okay. So this is the 1 point thing, right? So with the 1 point, we don't want for this code. So we want for this code, which is I didn't consider it. This part actually. So this is actually wrong. I need to do the removal afterwards, maybe. Is that true? Well, I mean, I don't know. I mean, I guess it doesn't matter because we have 3 B's. But here, we definitely need to check. Okay, so the last element, but also the first element of the index, right? So yeah, so if index is less than length of SL, then we also do this thing for yeah, and I think we're fine, maybe. Okay, YOLO submit. Okay, so that means that we just have to now copy this paste. Hopefully this is good. And what, just for science, I want to put this in. I mean, at this point, we are like I'm taking an extra minute, but that's fine. 5 minutes is. Ooh, I do like copy. 5 minutes is not, you know, like I think we're okay. We have 96, 23, 96, 23, 65, and then we have 44, 72, 72, 44, 44, right? So in theory, that should be -1. Just want to make sure that, I don't know, I'm sanity checking. Let's YOLO submit. Hopefully it's fast enough. Ooh, ooh, ooh. How does that happen? It doesn't, like how, what? They have different inputs. Leetcode, I hate you. I mean, this is probably the similar idea, honestly, but I don't know why they make it such that it is 100 maybe. I mean, this isn't even. Leetcode is just annoying. Like they're too lazy to write problems, so they do all these tricks to kind of trick you. Okay, fine. What is the, I mean, this -1, this is so annoying to read, but okay, how do I want to debug this? I have to convert this here, which is annoying as well. So maybe we can do, I still prefer it the other way though, so I don't know. So we have x. How much do we have? 45 minutes? I feel like we're just missing some edge cases, so we should be fine, hopefully. Oh, yeah, wait. Oh, I forgot to put this in there, that's why. I was like, what am I looking for? I'm not a smart boy today. Yeah, so we have this thing. Yeah, okay, fine. I have to convert this to a list, I think. Like, I don't get it. It's my, no, I guess this is not the invalid test cases because we have 20. Okay, I hate you, Leetcode. Okay, let's actually debug this then. Okay, so we have, how do I think about this? How I think about this is that I hate Leetcode. they, instead of writing real problems, they just make it annoying. Okay. Right, so it should be -1. So that means that, where's my best function? This function is here is wrong. Do I need to remove first? Maybe I do. Yeah, it will always be the next one. Okay, no, that's right. I think this is right in terms of whatever, but yeah, so we have x, px, yeah, px, y1, y2, right, maybe. 528, so we have this thing, so we have 91, 74, so we have 291, which makes sense. We have 85, but this is 40. 41 is also fine. We have 79, 41, 79. So these four is what actually the first four numbers will fit a square or whatever, but it should be -1 because I don't know. Well, nothing's on the border, so at least it's not that change. Unless I misunderstood this problem. What is going on? Yeah, 197, so I guess that's not so bad, but unless that didn't update. Yeah, okay. It should be better a bit. Okay, so something in the 80s maybe? Okay, this number should be inside. Why is 8150 not inside? Okay, so let's see. Okay. 8150. Okay, let's just print SL then. Keep it simple, stupid. In the debugging, we still have 40 minutes. Should have gotten this. Okay, so here we have, yeah, 44, 72, 20. That's, oh no, 23 is the X value. So okay, so I have 23 on the X. Where's 23 on the X? We don't have 23 on the X. Am I? Oh no, this is the wrong problem. I'm looking at. I need to do other things about it. Okay, so then now this is the last one. We have 3, 48, 65. 65 is the X, right? And we may have to remove 2 things. Maybe I didn't remove 2 things. That's maybe why. Okay. Because I see that now. Like, it doesn't make sense that this only removed 1 thing, right? Just the way that this is structured, maybe. Yeah, actually, yeah. Now that I think about it, no, but this should have removed this though for 1 point. This should have done it for it, but maybe it doesn't. Maybe I'm just being a little bit silly. Also, yeah, I can rewrite this now, I think. Just right here. Right. Okay, and then the previous one. But also, oh, because if it's Leetcode, then you also want to do this one. Okay, I guess so. But I thought this would remove it for me. But okay, let's see what the code does first. So 48. So something removed this. The 3 and 48 on the 65. Too much debugging. And then now you have this thing, which overlaps with this, which is already breaking the invariant, because it assumes that the 48 should not be. And 41 to 85 should have just removed this, actually. So I don't know, this is just so awkward. 41, 85, this is just very wrong, actually. Because this encompasses it, right? So, but these should have 2 indexes. But okay, I think yeah, I think this is like a little bit awkward as well as a result. But yeah, okay, fine. I think we could just do this. That's fine. This code is okay. But you know, let's see if that does anything first. Not so much. Still doesn't remove this, which is not great. Let's do the other side. That's not great, but this is also still not great. Whatever we moved the so at okay, let me print X on this so I know what to look out for. We have on 65 we added this bunch. On 69, not nice, but okay, so 69 with 41. So 41 we remove this thing, which is fine. Okay, so is there any other 69s? Nope. So that actually is right. And then on 79 we're 41 and 85, but that should remove this. I think that's well, that's one of the issues. Even if it's not the issue, it should be one of the issues. Why? So on 79, okay, we want to print remove. Okay, let's just print remove. I think remove doesn't change anything anyway, but what we want is maybe left index, right index. It may give an error because it doesn't do anything. Fine. So, but then now in 79 it's 0, 1. Maybe I was too conservative with this. Yeah, because it doesn't. Yeah, okay. But it still doesn't do it though. Why? 41 goes to 0. So this previous sorted list is going to be this. The 0 and 1. Am I too conservative? No, it should be. Is this going to be right? I mean, this fixes the answer, but I'm not confident enough to say this is right. Alright, let's at least give it for the other case. Let's make sure that this is still right for the other one, and then we'll eat more wrong answers if we have to, because Leetcode is just being a pain. Oh. I guess in this case we can reduce this to what's the number that we're looking for? Just like a 44 something, maybe. 8150, right? So I think this is the case that I'm breaking for anyway. Okay, let's run it real quick. So -1, so it fixes that. I don't know what I'm printing here. Honestly, why am I printing stuff? Where's my print? Oh, here. Well, that means that I printed my other one as well. So let's give it YOLO submit. Ooh, wrong answer. So that's good. I mean, now that was a free wrong answer, right? So yeah. What did I do? Okay. So now we removed too much. That's what I was worried about this thing. I wasn't sure about this, but okay. That's good, that's good. So here we want to keep this back up to -1. Wait, but now this fixes this, right? 1700 is right, but then, did I not try this? I'm so confused. Why is this giving me the wrong answer? I mean, I know the inputs are kind of wrong, so. Oh, maybe, no, this shouldn't be -1 though, if this is just these 5 things, right? Because we can, well, let's, this is one of those days where I know the answer, but I'm just not implementing it well. 8150, right? I mean, maybe they're just different problems. No, I mean, this is a subset of, or this is a subset of this, so this is impossible. This is, well, 528 may be one of the other ones, but that doesn't even make sense because the right answer is -1, so that means that there are other, even if, no, I mean, this is, I'm still, what is going on? And yeah, I don't know. I mean, there is some like really bad smell then. I mean, this is just not right, but okay, so let's get back here. But we have, okay, so we have 01, right? What does 01 mean, right? I mean, I guess we can just check for it. We can do even inclusive, really, right? So, which is that if SL of I in 0 is like, we can add a check. This is actually pretty easy. And in fact, we can even just do it that way with this and this, and then if this is less than then we could do this, right? So maybe we could do it that way. And still at 528 though, which is not the right answer. Why? Okay, so 48, so we have to remove this, and we don't. Oh no, we removed this, but we don't, right? We should, but we don't. Why? It's 01. So we check it inclusively. I think we can get rid of this actually now. Right. Does that help at all? I mean, all the other answers are rightish, but why? So we check 41 for. Oh, I'm looking at the other thing where 41 is in between this, but not the other way around. Okay, I see. I'm bad at. I'm bad. So we have to do something like right? Am I too slow? Is this complexity like crazy? I mean, I think this should remove all the other stuff only once, even though I had to add an if statement here. But honestly, it feels very clunky. Okay, let's at least give it an attempt to put it in the other one. I don't even know the other one helps me enough anymore, because this does some crazy things. Oops. Okay, we fixed the 17. Oh no, we don't. We didn't. Okay, that's not great. We also want to print out just so that I can also check it in the other thing, just to check the consistency. Right. So here we get -1. The right answer is 1700. Why is it 1700? Okay. Why is it 1700? Did I remove too much? No, but this is done afterwards, right? So this should be a chance to get it right. Oh, no, this should be precisely, right? We don't need to check one more, I don't think. But okay, I don't know anymore. Maybe I'm just being dumb, so let's just do it this way because I'm being dumb and I don't know anything, so if it works, then, you know, it's magical anyway. Okay, nope. Half an hour left. Okay, so here we want it to be 1700. Okay, so we have this thing. We start at 6. We have 1737. We're Gucci. We have, and then next is 88. We have 7 to 92. We eat this. Okay. Why is it 1700 then? Do we not eat this? 7 is between this and 91. Are they two different problems? I don't get it. There's not right? That'd be funny if all this time I was reading the wrong problem. No, it seems right. So why am I getting... What is going on here? 88, so okay, so so the 91, but then we have 88 on the 7. Oh, So on 88, we have 7 to 92, we think it overlaps, but it's actually outside the bound. So that's why we don't... So we don't get this for loop, right? Or this one doesn't make sense, maybe. Because then now, it's okay for it to be inside as long as it's wholly inside, right? So my overlap thing is, I mean, the overlap is fine, but that means that, what does that mean? So, okay, so the new point is inside the other segment is okay, but this one is not. Okay, maybe, or like, it definitely is not. Okay, so then now this is right, maybe. I don't know, let's give it a minute. Okay, so this is now right, maybe? Do I print stuff? No? Yeah, I print too much stuff. But, okay, so then is this right for the other case now then? At least that's all I care about. Okay, so, but it still gives me 528 for this input, which is a subset of this input, unless I did it wrong. Which this is -1, this should be -1. So we are definitely doing something really funky with respect to printing. Okay, let's see why it thinks this is 528. So we have, okay, so we have a 79. Actually, I guess, yeah, it doesn't overlap, so I guess this does not need to. But now the invariant doesn't hold anymore, where I think that's the issue, is that the invariant doesn't hold. Well, no, it just means that we don't add this because, wait, do we? No, it's okay to add this. But maybe my idea is wrong. I thought it would be contiguous, so my invariant is wrong. And then now this one will, well, 81, what is 81? 81 is the one with the 50. So 50, we removed this, but as a result, we don't remove this because we didn't think, because the invariant isn't that this is in two things. So, okay, I'm really bad at now. Okay, so how do I want to handle this? Huh, maybe I don't have this. How is this updating? Okay, yeah, it is pretty bad. But, how many people got it already? 116. How do I? I mean, we can re-index, but I don't think that changes anything. I don't know how to do it now. Now that I've been looking at this case for a while, and I've realized I am wrong. Well, I guess you can keep going, maybe. So, yeah. So okay, so this is the, because then now it can only be true if it's wholly in this, like, bigger, and that means that the left bound will be bigger, right? So maybe something like that. So okay, what does that mean? If this is true, then we do this, and then yeah, maybe while okay, so let's say right, so then we could do this. No, it would be pretty if no, not for this part, not for this part, because this part is matching, and the matching would be exact. I don't even think this is necessary, honestly, but so, or maybe this one's not the necessary one, so I don't think that makes sense. But for removal, we do, because we want, it's almost like popping off a stack, so then maybe you have a right? Else break, something like this, right? And we'll only check everything on the stack once, so in theory that should be okay. So s index -1, right? And I think this should fix it, but I mean, I'm not going to submit it because I think we have to fix it in a few places. Okay, maybe not. Why? We have a point at 81, 50, so 50, and that's the only point. So this should be the only place where it goes. Ooh, what the? Was that part of it? Maybe that's why. Okay, so that fixes it when we don't have a typo somehow. Okay. That is actually a curious thing. Okay, well, I mean, and while we're here, well, let's give it some love on Q3 first, and then before I kind of do more of it, I don't even care about the print. Okay, so that means that this is Gucci, but that means I probably want to remove a little bit more just in case. But I think this point should be good because we do it for every point, and we don't need to do it for here, do we? Because this should be a subset. What does this do again? I guess this kind of helps, but I don't think it's necessary. Do we ever go to the right? I don't know, I honestly. So I'm just going to do it this way, just because it's easier to just add these things. I honestly do not know. This stuff would be fine because we just go through all the loops. Technically we have to go back, I think, but all right, let's submit this on Q3 real quick, and then if it's I copied instead of paste. Okay. Maybe I have an infinite loop because I forgot to increment. Yep. Is it this one? Yep. So else break, otherwise s index plus. And you need the break because otherwise it goes into like n squared territory. Okay, let's click submit. Okay. So we did fix something. So let's put it back in. Okay. We do want to remove the print code. We don't have any print code. Let's YOLO submit. I mean, if it times out now, I'll be very sad, honestly. But, I mean, it is what it is. It's timing out. Because you push stuff off the stack, so then it should be brick, but, I don't know. Do they give you a test case or for hit in case? Thanks. Hit in case. I mean, I think this while loop is the sketchy part, so I don't know how to resolve it. I mean, but it should only, like, we remove it every time, so there's not like it does a lot. And we don't really, like, this part is maybe the other sketchy part. Maybe we need to remove this. Yeah, I think we don't need this because of what we have on the other thing, and the intersection thing doesn't really make sense anymore, right? Can we do without this part? Let's see. Maybe there's some like weird thing that I'm doing because of this loop. Like I think it didn't really, yeah. Okay, let's give it a submit. Okay, so that still works. So hopefully this fixed it. That was based off a misunderstanding, I think. So we'll see. Because this part should only happen on a stack. So okay. Whew, tough one for sure. Yeah, I mean, that's the annoying thing is that I knew how to do it for, you know, for a while, right? Like, you saw me debugging for the last 40 minutes, but it's still just like very hard to get it right. Oh my god. But you know, at the end of the day, still got it. So I'm a little happy. 20 minutes penalty. Q3 should not have a 20-minute penalty, but you know, or like I mean, I should have been better is what I mean. And we saved a lot of penalty by using it in Q2, is it? So it is wild. I don't know. Top 200 is kind of fine. Probably lose a little bit of rating. 12 minutes. Wow, people are so fast. I mean, this is also a problem that I feel like some people have code for, but maybe not. I mean, really smart people got it in 20 minutes. Oh, well, yeah, in 20 minutes. So yeah. Well, maybe they just did. Well, they also did it together, but I don't think like my Q2 did take 6 minutes. Why did I take 6 minutes on this one? I don't know. Well, I'm not going to know by looking at this code. Actually, let me double check my submission time real quick before I finish. Okay, 3 seconds is fine. Because if I was like at 9 seconds or something, I'll be like, well, let's kind of see if we can optimize some more. But yeah, I guess I didn't need, because I think the reason why I had it that way was that I thought I needed the loop. But I'm also curious because, oh, that's right. Because I thought that you remove everything in between. So then it makes sense to have the loop because you only remove everything once. But once I add the if statement, then now it is the invariant is no longer true that you always remove because you don't always remove. And in fact, you almost never remove because I misunderstood it. And so as a result, that just caused infinite loop. Okay, that makes sense. This is very hard. Like the way that, like the idea is pretty okay, but the concept is really hard, I think. Or the implement. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this problem, the description, the explanation, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.